2415 Calculus 3, Section 13.6, Parametric Surfaces and Their Areas, Video 5. Let's do another example of representing a surface by finding some parametric equations. In this case, we're going to do it two ways. Represent the surface z equals 2 times the square root of x squared plus y squared parametrically two ways. Answer number 1. And this is kind of a generalization of any time you have z equals a function of x and y, which we have here. Give me an x, give me a y, I can calculate a z. Then the easiest parameterization is to let x equal u, or rather u equal x, and v equal y. In other words, you're basically saying x and y are the parameters. And if you are, you don't even have to call in new letters. So let's not even do that. We're going to let x and y be the parameters. Parameters. So what's our parametric function? Well, it's not a function of u and v anymore. It's a function of x and y. Our x-coordinate is just the x. Our y-coordinate is just the y. And our z-coordinate is whatever we did to the x and the y. So 2 times the square root of x squared plus y squared. Okay, that's not too bad if you can write z as a function of x and y. And the truth is, if you can write one variable as a function of the other two, then you let those two be your parameters, and the third one as a function of those, it's done. But let's do a little bit more elegant answer. Because when you see x squared plus y squared, you should instantly think polar coordinates, or in three dimensions, cylindrical coordinates. So what if we let x equal r cosine theta, y equal r sine theta, which are your polar coordinates in the xy plane, then what would z equal? Z would be 2 times the square root of x squared plus y squared. But you know in polar that x squared plus y squared equals r squared. And of course the square root of r squared is r, assuming that the r is positive, which we can always assume, I believe. The minute I said that, made me second guess myself. But for now, let's just assume that the r is positive. How do y'all think of this? Okay, so r is positive. Then our vector function, which I really shouldn't call r since we're using r for the radius, so let's call it s. Nobody said your function had to be called r all the time. S of r and theta would be r cosine theta, r sine theta, and 2r. So which is the better representation? Well, it honestly depends upon what calculus you're going to do with your parametric representation. Speaking of calculus, I just noticed I skipped one. That's okay. I think at this point I'm going to stop and, if necessary, continue filming some more videos tomorrow.